Okay, so let's start with activity 3.2. Moving on to question 1, we have let A be the set of local minima and B be the set of local maxima for the function. They have given a function, so we have to find what are this local maxima and minima. So for the first step is we have to find all the critical points in this um, for this equation. So that is f dash of x. So that we have to equate that to 0, right? Will be what is f dash of x, so we have to differentiate 1 by 4 as it is. The differentiation of x to the power 4 is 4x cube minus 2 as it is. Differentiation of x cube is 3x square plus 11 by 2 into differentiation of x square is 2x minus 6 as it is, and differentiation of x is 1. So that is nothing but 0 equal to 4 and 4 will be cancelled, x cube minus 6x square plus 11x minus 6. Okay, so for this we have to solve this cubic equation. So for a cubic equation we know that we have 3 roots, right? So we'll go by elimination method. So that is, we'll go on substituting for the values of x now. For x equal to 0, what will be this value? That is nothing but minus 6. So x equal to 0 is not a root. So let's move on with x equal to 1. So for x equal to 1, we'll have 1 cube is 1, minus 6 into 1 square, that is minus 6, plus 11 into 1, 11, minus 6. So that is nothing but minus 6 minus 12, minus 12 plus 11 minus 1, 1 minus 1 is 0. This means that x minus 1 equal to x minus 1 is a root. Okay, so now we have to divide this x minus 1 by this equation, that is x cube minus 6x square plus 11x minus 6. So if we divide this, we'll have x square. So if we multiply with x square, we'll have x cube minus x square. So x cube is cancelled. We'll have minus 5x square plus 11x minus 6. Again we have minus 5 here, minus 5x here, so we'll have minus 5x square, minus into minus plus 5x. Again this will be cancelled. We'll have 11 minus 5 is 6x minus 6, again plus 6. If we multiply, we'll have 6x minus 6, remainder is 0. So therefore f dash of x is nothing but x minus 1 into x square minus 5x plus 6. To find the critical points, we have to equate that to 0. So the critical points are x equal to 1 or x square minus 5x plus 6 equal to 0. If we factorize this, we'll have x minus 3 and x minus 2 as the roots. So the roots will be x equal to 3 and x equal to 2. Okay, so now whether to find, we have 3 roots now. So to find the local minima or maxima, we have to use the second derivative method. So the second derivative here is x double dash of x. I'll just rub this off. Okay, I'll write here itself. X double dash of x is nothing but, we have to differentiate this equation, right? So that is nothing but 3x square minus 6 as it is into 2x plus 11. So that is nothing but 3x square minus 6 into 2 is 12x plus 11. So now we have to substitute all these critical points in this f double dash of x. So that is f double dash of, the first critical point is 1, that is nothing but 3 minus 12 plus 11. So this will be 14 minus 12 is 2. It is greater than 0. It means that this is a local minima. minimum. Okay, so f double dash of next critical point is 2. That is nothing but 3 into 2 square. 2 square is 4 minus 12 into 2 plus 11. That is nothing but 3 times 4 is 12 minus 12 times 2 is 24 plus 11. That is nothing but minus 1, which is less than 0. It means that 2 is a local maximum, right? So now last one, f double dash of 3. That is nothing but 3 into, if we substitute 3 here, we'll have 3 square. 3 square is 9 minus 12 into 3 plus 11. That is nothing but 9 times 3 is 27. 27 minus 12 times 3 is 36 plus 11. That is nothing but 27 plus 11 is 28. 28 38. 38 minus 36, that is 2, which is again greater than 0. It means that this is also local minimum. So here the set A is the set of local minimum. So we have local minimums are 0 and 2. What about maxima? We have only one maximum, that is x is minimum is 1 and 3, right? 1 3, maximum is 2. That is the last option. Moving on, we have minimum value of the polynomial p of x is equal to x minus alpha into x minus beta. That is p of to find the minimum value, we have to first find the critical values, and from then we have to find the minima, right? So p dash of x is nothing but, we have two different x here, so we have to apply the product rule. So for the product rule, we have to first differentiate x minus alpha, so we have 1 into x minus beta as it is, plus now we have to keep x minus alpha as it is, and we have to differentiate x minus beta. X minus beta differentiation is again 1. Okay, so now if we equate this to 0, that is 0 equal to x minus beta plus x minus alpha, that is nothing but 2x. I'll send beta and alpha to the LHS, that is alpha plus beta. This implies that x equal to alpha plus beta divided by 2. Okay, so this is a critical point right now. So we have to check whether this critical point is a minima or maxima, right? So for that I have to use double differentiation, second derivative, that is p double dash of x is equal to, now I have to differentiate this equation, that is nothing but differentiation of x is 1, beta differentiation is 0, again x differentiation is 1, alpha differentiation is 0, that is 1 plus 1 is 2. Regardless of whatever value of x, we'll have 2, that is p double dash of alpha plus beta divided by 2 is equal to 2, that is greater than 0. This implies that alpha plus beta divided by 2 is local minimum. Okay, so now what is this, what are they asking? The minimum value of the polynomial function, that is nothing but alpha plus beta divided by 2. Next one, we have x plus y is equal to 50. We have to find the maximum value of 2x, 2 into x plus y. Okay, so we have two variables. Can we use can we convert this one of the variables in, can we have this equation in terms of only one variable? Yes, we have another condition, right? So according to this condition, I can write y is equal to 50 minus x. I'm just sending the x to the RHS. So I'll substitute this in the given equation, that is I'll write this equation as f of x, that is nothing but 2 into x as it is, y I'll write as 50 minus x. So now if I differentiate this, f dash of x is nothing but I can further simplify this as 100x minus 2x square. Now if I differentiate this, I'll have 100 minus 4x. So now if I substitute this as 0, I'll have 4x is equal to 100. This implies that x equal to 25. So x equal to 25 is a critical point. So since I have only one critical point, I can go I can check also whether this is a minima or maxima, or I can directly find out the value of f of this critical point, that is x equal to 25. That is nothing but 2 into 25 into 50 minus 25. That is nothing but 2 into 25 into 25. 25 square is 625. 625 into 2 is 1250. This is the answer. Moving on, consider a rectangle of length L and width W such that the perimeter of the rectangle is 100 units. So if we have a rectangle something like this, the length is L and the width is W. What is perimeter? Perimeter is 2L plus 2W, that is given as 100. So if I take 2 common, I'll have L plus W as L plus W is nothing but 50. Okay, so now the maximum possible area. What is area? I'll have L of area is given by length into W. I'll just convert this L in terms of W. I'll have area in terms of width, that is nothing but 50 minus W into W, right? So now a dash of W, I have, again if I multiply this, I'll have 50W minus W square. If I differentiate, I'll have 50 minus 2W. So if I substitute this as 0, I'll have 2W is equal to 50, and this implies that W is equal to 25. So to check whether this is maxima or minima, I'll have to double differentiate, right? A double dash of W. Again, this step is not necessary. We can directly substitute this in terms of this W value in this equation and directly find the answer. Just for practice sake, I'm doing this. If I differentiate again, I'll have minus 2. Minus 2 is less than 0. This implies that this is a local, this is a maximum. Okay, so now A of W equal to 25 is nothing but 50 into, I'll substitute here, right? 50 minus W, 50 minus 25 into 25. I'm substituting in this. Okay, 50 minus 25 is again 25. 25 into 25 is 625. Second option is the right one. Moving on. Okay, so I have split equations here. Which of the following options are true? They are talking about different numbers here. So now I'll just have to first differentiate this, correct? So what is f dash of x? F dash of x is nothing but differentiation of this one, that is minus 2x plus 2, right? Here this is for 0 less than x and less than 50. What about this one? Differentiation of x cube plus 3, that is nothing but 3x square. This is for minus 50 less than x and less than 0. Fine. Now substitute this f dash of x as 0 for all of this. So now for this equation, minus 2x plus 2 is equal to 0. This implies that 2x equal to 2, meaning x equal to 1. Does x equal to 1 belong in this interval? Yes. So this is a valid critical point. What about next one? That is 3x square is equal to 0, implies that x equal to 0. Does this x equal to 0 come under this interval? No. So now if we go with whether this one is local minimum or maximum, right? So we have to go with f double dash method. F double dash of x is nothing but, if we differentiate this again, we'll have minus 2, and if we differentiate this again, we'll have 6x. This is for 0 less than x and less than 50, and this is for minus 50 less than x and less than 0. So now what about this one? F double dash of 1, that is nothing but this comes in this one, right? F double dash of 1 is minus 2. This is obviously less than 0, meaning that we have local minimum. Alright, so now considering all the intervals, I'll have to find out all the different values for f for the function, right? F of, I'll start with least value, that is minus 50. F of minus 50 is nothing but, I'll have to use this equation, that is 3 into, this equation, that is 3 plus minus 50 whole cube, that is nothing but 124997. Okay, so now I'm done with this. I'll move on to f of 0. Again, f of 0 is nothing but, I'll have to use this equation. So again, I have 0 square plus 2 into 0 plus 3. I'll have only 3 here. Okay, now f of 1, the critical point that we have. F of 1 is again, we have to use again this equation, that is minus 1 plus 2 into 1 plus 3, that is 2 plus 3 is 5, 5 minus 1 is 4. Again f of 50. Again we'll have to use this equation, that is nothing but minus 50 square plus 2 into 50 plus 3, that is nothing but minus 2500 plus 100 plus 3, that is nothing but minus 2397. Okay, with these values we can say that, what about 1? 1 is a local maximum. Yes, we have already, I'm sorry, I've written this reverse. If f double dash of 1 is less than 0, then 1 will be local maximum. It is vice versa, right? I've made a mistake over here. Alright, what about in this interval, which is the least value? The least value that we have is for this one, that is f of minus 50. Therefore minus 50 is the global minimum. Global minimum is nothing but, the global signifies that in the given interval, that is from minus 50 to 50. That is the given interval, right? In this given interval, for minus 50, f of x value will be least one. That is what we have found out. Okay, now what is f of 0? F of 0 is 3, but we have another value which is greater than 3, right? So this is not the global maximum. What about 50? 50 is also not the global minimum. Okay, the option 1 and 2 is the right one. Moving on, question 6. We have a function f of x equal to x by n plus n by x in the interval 0 comma infinity, where n is a positive integer. Okay, so now again same method, we'll have to find out f dash of x, that is nothing but differentiation 1 by n is constant, so differentiation of x is 1, we'll have 1 by n plus n is a constant, differentiation of 1 by x is minus 1 by x square. Now if we equate this to 0, that is 0 equal to 1 by n minus n by x square. This implies that n by x square is equal to 1 by n, meaning x square is equal to n square, implies that x equal to n. Okay, x equal to 1, n is a critical point. Moving on, f double dash of x, what is this? I have to differentiate this again. Alright, so this will be 0, minus n is a constant, differentiation of minus 1 by x square. If we differentiate this, 1 by x square, differentiation is nothing but minus 1 divided by x cube, that is minus 1 by x cube. Now f double dash of x is nothing but minus into minus plus, that is n by x cube. Now what is the critical point that we have? That is f double dash of n, that is nothing but n divided by n cube, that is 1 by n square. So they have given that n is a positive integer, right? For all positive integer, this 1 by n square is always greater than 0. If this is greater than 0, what will be n? N will be a minimum, right? So now if let us forget about this interval given, right? If we are forgetting about the interval, then this n will be a local minimum, right? Okay, so now we can say that n is a local minimum, right? So what about if we consider 0 comma infinity? Okay, so now what are the different values of this function at these endpoints, right? Let us see what is f of 0. F of 0 is nothing but 0 plus n by 0 will have infinity, right? What about f of infinity now? So to find this, we'll have to find limit x tends to infinity of f of x, that is nothing but limit x tends to infinity of x by n plus n by x. So we'll have, again this will be infinity. This means that this function is a diverging function, right? The limit does not exist, right? It means that as the x value goes on increasing, f of x value also increases. So we cannot say that n is the local maximum. This is wrong answer. So at 0 as well as x, the value is larger, right? So we can say that in the given interval, n is also a global minimum, right? So n is a global minimum. Moving on, f of x is equal to sin x plus cos x plus phi. Which of the following is the maximum value of the function in the interval 0 comma pi? Okay, so we have to find the maximum value of this function in the given interval. Okay, so first step is differentiation of the given given function, that is f dash of x is nothing but differentiation of sine is cos is minus sine, constant is 0. Alright, so if we equate this to 0, we'll have 0 equal to cos x plus cos x minus sin x. It is nothing but sin x equal to cos x. So now in the given interval, that is from 0 to 180 degree, for what values we'll have sin x and cos x as 0? We have only one value, that is 45 degree. Only for 45 degree, sin x will be equal to 1 by root 2 as well as cos x will be equal to 1 by root 2. Okay, so in the second quadrant, we also have 180 minus 45, right? Observe, remember that in second quadrant sin is positive but cos is negative, so we have only one value, that is 45 degree. Therefore this solution of this equation is nothing but x equal to 45 degree. This is a critical point. Okay, so now whether this critical point is maximum or minimum, right? So for that we have to go with second double derivative method, or directly we can substitute this 45 degree in the f of x and we can find out the maximum or minimum value. Since we have only one critical point, that will be the maximum value, right? So we have f of x equal to pi by 4, that is nothing but sine of pi by 4 plus cos of pi by 4 plus 5, that is nothing but 1 by root 2 plus 1 by root 2 plus 5, that is equal to 2 plus 2 root 2 plus 5, that is nothing but root 2 plus 5. Option 3 is the answer. Last one, we have f of x equal to a function. We have a polynomial function. Which of the following options is or are true about the function f of x? Okay, so they have given, they're stating that increasing or decreasing function, right? So first we have to find out the critical points for this function. To find the critical points, we'll have to go with differentiation of this, that is 1 by 5 as it is. Differentiation of x to the power 5 is 5x to the power 4. 5 and 1 by 5 will be cancelled, so we'll have x to the power 4 minus we have 3 by 2 into 4x cube plus 11 into 3x square divided by 3 minus 3 into 2x. So now this is nothing but x to the power 4 minus 6x cube plus 11x square minus 6x. Okay, so now we can say that can we take x common here? Yes, so that is nothing but x of x cube minus 6x square plus 11x minus 6. Okay, so now if we simplify this, we'll have x into x minus 1 into x minus 2 into x minus 3. The simplification is similar as in question 1. Okay, let me check whether this is question 1 or not. Yeah, the simplification is similar as in question 1. Okay, now what will be, if we equate this to 0, we'll have x equal to 0, 1, 2 and 3 as the critical points. Okay, now whether to check whether these are maxima or minima, we'll have to go with the double derivative method, that is nothing but f double dash of x. F double dash of x is nothing but, we have to differentiate this one, so I'll have 4x cube minus 6 into 3 18 x square plus 11 into 22 x minus 6. Now I'll have to find f double dash of 0, that is nothing but minus 6. So this is obviously less than 0. It means that we have a local maxima here. Now f double dash of 1, that is nothing but 4 minus 18 plus 22 minus 6, that is equal to 2, which is greater than 0. It means that we have a local minimum at x equal to 1. So x double dash of 2, that is nothing but 4 into 8 minus 18 into 4 plus 22 into 2 minus 6. After simplification we have minus 2, which is less than 0, meaning that x equal to 2 is a local maximum, right? F double dash of 3, now we have 4 into 3 cube is 27 minus 18 into 3 square is 9 plus 22 into 3 minus 6, that is nothing but after simplification we'll have 6, which is obviously greater than 0, meaning that we have local minimum. Okay, so now for just visual representation, I'll have, let's say this is x 0 1 2 and 3. So let's say this is, I'll have f of x over here. What about at 0? 0, I'll have local maximum. Let's say something like this. Okay, I don't know how the graph behaves from 1 to 0, but I'll have a local minimum at x equal to 1, meaning that I'll have a trough here, right? And at x equal to 2, I'll have again a local maximum, meaning that I'll have a crest here. At x equal to 3, I'll have a local minimum, meaning that I'll have a trough here. Okay, now in the interval 0 comma 1, for they're saying that in function f of x is increasing in the interval 0 comma 1. In 0 comma 1 it is obviously decreasing, correct? So from 0 it starts to decrease, and again at the vicinity of 1 it is decreasing again, and then it will start to increase after 1. So from 0 to 1 the function is decreasing, but they've given it as increasing. The first option is wrong. What about second one? Second one, the given interval is 2 comma 3, right? So here the interval 2 comma 3, I'll have after 2 the function start to decrease again till x equal to 3, the function is decreasing still. So they have given us function f of x is decreasing in the interval, right? Second option is right. What about third one? Increasing in interval 1 comma 2. 1 comma 2 it is increasing. Yes, third option is also right. What about fourth one? Fourth one we have 3 comma infinity. So from 3, since they have not given any interval and we have not checked in any interval here, these are the only maxima and minima for this equation in from minus infinity to infinity, right? So from 3 comma infinity the function goes on increasing. Again this option is right. What about 1 comma 3? 1 comma 3 we have a change of direction, so this option is wrong.